Hello student. Hello student. Today we are going to third lectures on solid state physics. So today's point is a metallic bonding. So in this case, in metallic bonding, in metals numbers of so again in metallic numbers of for metallic molecules. So in this case, metallic bondings is our first point in this period. Metallic bonding in metallic numbers of uh, free electrons are more, right? In metallic numbers of free electrons are more. Therefore, therefore, it has it has high electric conductivity. What is this? Therefore, it has high electric conductivity. Electric conductivity cannot be controlled. Okay, cannot control by by controlling potential difference. Okay, electric conductivity of the some materials when it is in metallic form, when it is a metallic form, okay? When it is a metallic form, when it is a metallic form, and when it is a in a semiconductor form, isn't it? कसं असलं पाहिजे? When it is a metallic form and when it is a semiconductor form is not similar in semiconductor form, is not similar, okay, is not similar, is not same, sorry, not similar, not same in semiconductor form. आपण परत बघूया या पॉइंटला. When metallic numbers of free electrons are more, त्याच्यामध्ये free electron हे जास्त असतात. Therefore it has high electric conductivity. Electric conductivity cannot be controlled by controlling potential difference. Okay. Electric conductivity of the same material. Right? Electric conductivity of the same material when it is in a metallic form. जेव्हा ते metallic form मध्ये असेल. When it is a semiconductor form आणि ते semiconductor form मध्ये असेल is not same. काय ते सारखे नसणार काय when it is in semiconductor form is not same. काय मेटॅलिक फॉर्म मध्ये असेल पण त्यावेळेस ते सेमीकंडक्टर फॉर्म मध्ये नसेल. ओके, याचे कॅरेक्टरिस्टिक काय आहे? कॅरेक्टरिस्टिक्स ऑफ मेटॅलिक क्रिस्टल. ओके, मेटॅलिक क्रिस्टल हाय इलेक्ट्रिक काय हाय इलेक्ट्रिकल थर्मल कंडक्टिव्हिटी. काय असेल? हाय इलेक्ट्रिकल थर्मल कंडक्टिव्हिटी. सेकंड, हाय ऑब्झॉर्प्शन कोएफिशिएंट. high absorption coefficient. Okay, and and bonding energy. Third काय bonding energy of metallic crystals depends on number of free electrons. कशावर? Binding energy of metallic crystals, okay, depends on number of free electrons when it is in a semiconductor form, isn't it? So next, खूप त्रास देतो त्याला. So next, हायड्रोजन बॉन्ड. आता हायड्रोजन बॉन्ड मध्ये आपण लक्षात घेऊया. Natural hydrogen has only one electron. It should form a covalent bond. कोणता असेल? Covalent bond with only one another atom. Okay. If is known, however, that under the certain conditions an atoms of hydrogen is attracted by rather strong forces to two atoms, thus forming what is called the hydrogen bond between them. Okay. मग या दोघांमधलं कोणाला हायड्रोजन बॉम्ब म्हणायचं? मग in the extreme ionic form of the hydrogen bond, the hydrogen bond loses its electron to another atom. Okay. In the molecules. Okay. Their their Bohr proton forms the hydrogen bond. Okay. The small size of proton permits only two nearest neighbors atoms. Okay. Two permits only two neighbors, nearest neighbors atoms. Because the atom adjacent to the protons are so close that more than two of them would get in each other way. Thus, the hydrogen bond connect only two atoms. Okay, the hydrogen difluoride ions H fluorides is stabilized by a hydrogen bond. See, there is a fluoride. The two atoms is contacting one hydrogen. Okay. So the hydrogen bond is a important parts of the interaction between two HO, water molecules like this, H2O molecules, isn't it? So atomic and ionic radii. आता इथं बघा, इथं दोन फोर ॲटम दाखवलेले आहे, आर आर, देन खाली ते जॉईंट केलेले आहेत. हां, बघू आता काय. द ॲटॉमिक रेडियस डिनोटेड बाय आर is defined as half the distance between the two sides, between the sides of the unit cell. Then, then the atom radius r is equal to a upon 2. Okay. कट झाले ते झेरॉक्स मध्ये पुस्तकात. So the atomic radius r is defined as half of the distance between the nearest neighbors. Okay, if A is the side of the unit cell, then the atomic radius is equal to r is equal to a upon 2. Okay, so बघा ती figure. Study of the atomic radii given valuable informations about the structures. Okay, study of atomic radii given valuable information about the structure, since all the atoms in a solid are assumed to be identical. Okay, that is R is equal to A upon 2. For example, in case of sodium metal Na, the sodium metal, the nearest neighbor's distance is 3.72 degree angstrom. Okay, hence, the atomic radius of sodium is taken as 1.86 angstrom, isn't it? Radius of radius of Radius of the atom is a difference for crystal structure. Metallic solid Radius of the atom is a difference for crystal structure. Metallic solid and vapors term, that is the radius of sodium atom. In metallic, sodium is 1.85. Same sodium atom is in ionic bonding. Is ionic bonding As the radius of 0.98 angstrom radius of the atom in ionic and metallic bonding is a different. In vapor form, radius of sodium atom is a more as radius of sodium atom is 1.85 angstrom. Metallic and for same metals, inter interatomic distance is 3.71 3.718 angstrom. Radius of the atom is exactly half the distance between the two atoms. Similarly, a, a crystal structure is formed by sodium ferrous, and the distance between two successive atoms is 2.32. Therefore, the radius of the F atom म्हणजे fluoride is 0.47 angstrom. By X-ray diffractions, by the X-ray diffraction, if is observed that radius of fluoride atom is 1.3 to 1.4 angstrom, which does not coincide with theoretical result. Therefore, radius of the atom in crystal structure depends on what type of crystal structure is there. Knowing the interatomic distance is denoted by A for any crystal structures, and knowing the radius of one atom is denoted R1, we can determine the radius of R2 of the other atom depends on the types of bonding is therefore only on which types of bonding is there. Okay. आता आयोनिक कंडक्टिव्हिटी आयोनिक कंडक्टिव्हिटी मध्ये काय आहे खूप कापलं गेलेलं आहे पोरीने काय बरोबर केलं नाही लास्ट पॉइंट है आयोनिक so ionic conductivity if a potential difference is applied across the conductivity for metals, electric current flows through it. This is the because of the conductivity of large number of electron in in it similar if similar if a potential difference a potential difference is applied across the two positive forces. If one ionic crystal sodium chloride, potassium chloride on electric current flow through it very few numbers of free electrons. Free electrons are available in ionic crystals. The large magnitude directions of the observed magnitude of observer current depends on upon this current cannot be contributes due to conductions electrons. Okay. Naturally, if must be the ionic that are responsible for conductivity current due to ions is called ionic current. It is a very small. It is a very small. Okay. So this chapter is a finish here. So next period we are starting fourth chapter on solid state physics.